All right, so what are some of the underlying principles for water sensitive urban design? This is important because, as I say, in different parts of the world and in different regions within single countries, different terminology will be used, but broadly speaking, the principles are the same. And if we understand the principles, we're less likely to get confused or to do things that perhaps might look nice, but not actually going to achieve the things we want to achieve. So the first one, fairly obvious, and I think most of these should be fairly self-evident. Consider all parts of the urban water cycle, both the natural and the constructed, surface and subsurface. Understanding that all of these things are connected, and so when we do things to one, we're going to have an impact on other. And I'll give the example of wastewater recycling, which we've talked about, and also stormwater harvesting. So both of these are very commendable initiatives. Both have benefits to the environment. But if we don't think about how the system works together, and for example, we decide we're going to implement widespread stormwater harvesting in a new residential precinct, if that area has already been, for example, mandated or equipped for wastewater recycling, we may then find we have more water available to the community than there is demand. And we'll talk about some of those volumes later, but we might then find that we can't find a way of essentially paying for those. By having understood that interaction at the start, we can think about, okay, we've got all this excess of water, where else nearby could we go looking? Is there, for example, an agricultural area nearby that may make good use of that water? Could we pipe that water to agricultural areas? Consider all requirements for water, both human and environmental, and try to think about how to deliver both. Consider the local context and the broader impacts, accounting for all of the perspectives from cultural, from social, environmental. And this is really important. We tend to, in the past, I suppose, rely on fairly standardized approaches, standard drawings, etc. And whilst that can still be helpful in water sensitive urban design approaches, we need to understand that we have to make something work in the local environment. So a simple example would be different types of plants will work better in different environments. So a plant that I might use in an arid area is not going to be the one I use in a tropical area. And so we need to, at the very least, think about that. But for a whole range of design elements, we need to think about the local context. Include all stakeholders in the decision-making process. We've already said that we've now got multiple objectives. We've got multiple benefits potentially. So we need to involve those who are potentially going to benefit or disbenefit in that process. Strive for sustainability, balancing environmental, social and economic needs in the short, medium and long term. And I'll just pick up on this concept of long term. We need to make sure that we have appropriate monitoring and maintenance in place to allow our systems to work well and be assured to work well in the long term. And really the objectives of the Mine for Stormwater program are exactly about that, equipping us with the tools to allow us to do that in a cost-effective way. I think most people who are experienced in water sensitive urban design from around the world, if you ask them to list the 1, 2 or 3 top barriers or challenges, they would identify long-term maintenance and monitoring as absolutely in the top 3 barriers. And myself, I would list it as the number 1. So this is really an important area. So is it really possible to achieve all of these objectives? Well, of course, by definition, we've now got multiple objectives, so we're going to have conflicts. And our job is, of course, not to necessarily get the optimum outcome for each objective, but to get the optimum across the objectives, a classic sort of optimization problem. The key to getting there is to understand the objectives. If we don't know what our objectives are, we can't know whether our design or our approach is going to achieve it. And those objectives really need the views of the stakeholders to inform them. Okay, let's talk a little bit about how we achieve effective implementation. What are some of the principles that will achieve that? The first is to facilitate innovation, to allow the market, if we want to call it that, but to allow people to come up with clever ways of doing this. This is something that one of my great mentors, Tony Wong, has always drummed into me, and I think it's a really important one. If we tell people, if our objective is to reduce potable water demand, and we tell everyone you must install a rainwater tank, by and large, that's the outcome we get. But if we instead tell them you must achieve whatever our targeted reduction in potable water use is, they may come up with a whole range of methods of achieving that. Now, this may be a little bit more difficult from a compliance point of view, probably is, but it could mean much cheaper and more what I'd call material effective, so lower use of material solutions. For example, the use of water saving appliances and water saving kind of behaviours may achieve the same outcome and use much less carbon dioxide emissions, for example. So, and an economist would tell us that by encouraging that innovation, we allow the economic optimum to be found. And so it's a principle I must say I do hold very dearly. Recognising the clash, I suppose, or the conflict with the ability to simply communicate and ensure compliance. Be open to multiple solutions, and so this is in some ways related. So the first and most important thing is to separate the identification from solutions from the objectives. First of all, work out the objectives. You can't know what are the good solutions until you know what it is you're trying to achieve, and those objectives should be measurable to allow you to then do modelling or design analysis. And time again, we see, and Frederick and I have both seen many examples, including ones quite close to us, where systems are installed without really a clear sense of what's being tried, what was the objective, what was trying to be achieved. And so then we see solutions that are really not well thought out. And I must say, I see this very commonly also in groups I work with, where straight away people say, oh, we can install this here, we can install this here, we can do that, we can build this. Great. But what are the objectives we're trying to achieve? And so as exciting as it might be, will it achieve the objective? Set clear, measurable objectives. So we've covered this. They should be measurable to allow us to measure performance. I can't stress it more strongly. Consider other dimensions. Again, this is part of that broader, sustainability. There's no point, for example, in achieving a great water outcome that uses huge amounts of energy or produces huge amounts of waste material that can't be dealt with. So we need to think about that. Use partnerships. I think we've covered this. By definition, water sensitive urban design or integrated urban water management, whatever we want to call it, is multidisciplinary. It's not just a job for an engineer. It needs botanists. It needs social scientists. It needs economists. It needs monitoring experts. It needs maintenance teams. One of my strongest memories is designing a fire retention system, and I deliberately involved the head of the maintenance team in the design, and he straight away looked and he said, you've put the inlet pit, it was a surcharge pit, inlet pit right in the middle of the rain garden. How on earth is my crew going to get in to clean that out? And he proposed a simple change, allowing that pit to actually sit sort of outside of the system, that all of a sudden made it incredibly easy for them to park a truck right next to the system, deduct material out of that pit, and reduce the amount of times they'd have to go into the main basin. Such a simple solution, but if I hadn't have engaged those kind of people, wouldn't have even known about it, wouldn't have thought about it. Consider the local context. We've talked about this. So we really are not just putting the same biscuits every time, cutting the same cookies. We're designing solutions that match the environment. Assess economic performance. So ultimately, as desirable as all of these principles are, we need to ensure that they are sustainable from a financial point of view, and we need to be able to communicate to the community, well, what are the costs, what are the benefits? And so that means using appropriate life cycle costing, cost-benefit analysis tools to allow us to do that. And of course, there are some non-monetary costs and benefits we need to consider, and so we need to have ways of quantifying those as well. We also need appropriate design analysis and design tools, and in most countries in the world now, there are readily available tools to allow us to do that. A really important thing is to monitor performance. So that often is a legal requirement, but it's absolutely critical if we are to learn and improve our systems, and recognizing this is an evolving practice. But really importantly, we cannot ensure the long-term performance of these systems if we are not monitoring them. And the Mine for Stormwater program is really about trying to tackle that challenge to create low-cost technologies that allow us, for example, for an infiltration system, to just track the water level in it and say, oh, hang on, it seems to be taking longer than it used to for water to draw down. I think we should get someone out to have a look at that. Or a rainwater tank to say, oh, that's strange. It rained 10 millimetres, but according to the catchment area, only 2 millimetres of rain went into the tank. Perhaps the inlet is blocked, and to tell the owner that that's the case. And so really, if we're to see these systems be sustainable in the long term, we need to have ways of knowing when they're working and not, and monitoring is